scatter plots and the line y equals x. In a class, students were asked to X each of these boxes, first with their right hand and then again with their left hand for a minute at a time, and figure out in that minute how many boxes they were able to cross out. The worksheet looked like this. So to put you more in the moment of the experiment, here's an example of what happened in the class. Here we have Joel and we have Matt over there, and we're going to do an experiment and see how many boxes they can. Oh, we have Ruben timing, yay! And we're going to see how many boxes that they're going to X out in a minute using their right hand. Ruben?
Ready, set, go!
Oh yes, exciting video. Oh yeah, so that's how it's going for. That's kind of boring, and look, they're still doing more X's, and then they do it with their left hand, and they add up how many they got correct. Because you can't add, or because you just didn't do that?
Finish the rows.
126.
You didn't finish the rows.
All right, and then they would repeat the process with their left hand, but I'm not going to videotape that. Actually, let's do it. Let's do it. Ready? Ready? Just the beginning.
This
was funny.
And
ready? This is what it looks
set,
like.
go!
Oh my god, this is so hard.
All right, that's Joel's pitiful left hand. There you go. Now you're in the experiment. Where's Matt's? Yeah, I don't even know if he's going to make a row.
Wow, thanks for the
All right. Here's a snapshot of the data that we obtained in the class. The first person had 121 X's with their right hand and 53 X's with their left hand. And so on the scatter plot, that will be the point 121.53. Notice on a scatter plot, oh, I've got to move this, sorry. Notice on a scatter plot that, why is it not moving? There we go. That your axes are both data. It's not frequency on the y-axis. You've got a left-hand count of data here on the y-axis, and there's also data on the x-axis. So a scatter plot compares two different data sets, and what you're going to do is just use your coordinate system to graph these points. So the point 121, 53. Oh, before I do that, notice that I first took into consideration, because I'm going to make a square grid here for a reason, and the max x of x and the y's, the max was 125 and the minimum was 22. So that's how I got these axes here, from 20 to 140 for the right hand count, and I just squared it out with the y's. So the first point, 121.53, to graph that, I'm going to, on the x-axis, look for 121. There's 121, but I'm not going to make a point there. I have to go where it intersects 53 over on the y-axis, so there's going to be a point right about here. So there's my point on the scatter plot. And for the next person, 49 X's with their right hand, 102 with their left, and that would correspond to the following point here, roughly there. Okay. I would continue to do this until I finish making the scatter plot. There, I finished making the scatter plot. So as we look at the scatter plot, there actually does not seem to be any kind of shape. It's just a big mess. So later on, when we talk about linear correlation and regression, there wouldn't be much application to this data. But there is a line that does make sense to check out and compare this data to, and that's the line y equals x. And on the line y equals x, that is the line where all the x values, for example, the point on the line y equal x would be the point 20, 20. That would be a person who got 20 right-handed x's and 20 left-handed x's, the same amount. So another point on that line would be 100, 100. So you would connect the dots to make your line y equals x, and so on. And I have a better picture on the next slide, so let's go to that. So finally, here's the graph of the line y equals x along with the scatter plot. So the line breaks up the data into, or it breaks up the quadrant into two regions. And on this region to the right of the line y equals x, in all those points, you'll look, if you pick any of those points, in all those points, the x value is bigger than the y value. So what does this mean? This means that they had more of the boxes checked with their right hand than they did with their left hand. So that means that these people are probably, everybody? Oh, they weren't even listening. I've got people in the room here, they weren't even listening. They're probably right-handed. Thanks, guys. And now they don't think anybody's in the room. Somebody say something so they don't think I'm talking to myself. Yay, okay, see people in the room. Okay, cool. And then over here on the other side of the line y equals x, over here on the other side of the line y equals x, these people had more counts with their left hand. So these people, the y was bigger than the x, and so these are my left-handed people over here. Lefties, and these are my righties. Probably. I mean, there could have been something else that happened that made them not do so well with their right hand. Notice another thing, too, if you wanted to look for someone who is ambidextrous, you're going to be now looking for someone who is close to the line y equals x. In this data set, this person's pretty close, but they didn't do very well with either hand, so I wouldn't probably use them to be my ambidextrous example. But it looks like this person is the closest, and maybe this person over here is the closest to that line y equals x. If we had somebody right there on the graph, that person would probably be very close to being ambidextrous. So this is just an example of how looking at the particular line, again, the line y equals x is absolutely not the regression line, but it does split the data into two parts that sometimes makes sense to look at. So now online we have the married couples handout that you can work on. It considers the line y equals x, and enjoy your studies with that. More to come on the regression line, another exciting line with a scatter plot.